Good morning, everybody. We'll begin today's session now. So this is the first question for the day. You to find the maximum number of equilateral triangles of 3 centimeter side that can be fitted in a large equilateral triangle of length 11.2 centimeters. So this is how the organization will happen, where the bigger equilateral triangle is of 11.2 centimeters. This is an equilateral triangle with all its sizes 11.2. And the smaller equilateral triangle is of 3 centimeters with all its sizes 3. The total number of equilateral triangles that we can see which can be fitted here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So a total of 11 equilateral triangles can be fitted in a equilateral of 3 centimeter side can be fitted in a bigger equilateral triangle of length 11.2 centimeters. Okay, move to the next one now. Here you're given below images drawn with same set of equations but with different parameters. The parameters are different, which means the logic of how these numbers and the figures relate is the same, but the numbers are different here. The parameters used to generate the figure are given below. Here to identify the correct set of parameters which would generate the figure shown on the right, this figure. So now here, if you look at all the diagrams, this is a 5-sided, this is also 5-sided, this is a 4-sided, this is a 27-sided, and this is a 3-sided figure. 3 means 1, 2, and 3. So how this 5 comes? When you divide 10 by 2, we get 5 here. 10 by 2 again 5. 16 divided by 4 comes 4. And 108 divided by 4 gives 27. Which naturally means that capital R divided by small r has to be equal to 3 because the 3-sided polygon in the last figure or in the figure on the right. So on all the options, in the first case, r by small r is 3. Next case, capital R by small r is 4. Next, capital R by small r is 2. And in the next case, capital R by small r is 8. So B, C, and D are wrong, and A will be the correct option. Okay, move to the next one now. It's 12 o'clock and the hour and minute hands are aligned exactly one over another. Both hands move continuously. After how many minutes will they meet again? So here, first thing that you will have to understand is that the hour hand will move by 5 ticks in 60. Our hand will move 5 ticks in 60 minutes. So, one second. Our hand will move 5 ticks per 60 minutes. 5 by 60 ticks per minutes, basically. Okay. Also, based on that, the hour hand movement will happen 5 times, basically 5 times between when it moves from 12 to 1 and then aligns itself. So 5 times, which is equal to 5 multiplied by 5 by 60, which equals to 25 by 60. When you further resolve it, it comes to about 0.416. It comes 666, but let me write 0.4167. Okay. So the hour minute hand alignment after 12 o'clock will happen at 12 will happen after 1 hour plus 5 minutes. It has to be 1 hour, 5 minutes, and then plus 1 second, and then plus the movement that the hour hand will go through, which we have already calculated 0.4167 in the 5 minutes timeline. So it comes to about 60 plus 5 plus 0.4167, which comes to 65.4167 minutes. So the answer is 65.4167. Okay. Move to the next one. Here you're asked, at most means maximum. At most, how many spheres of same size can be placed around a same size sphere at the center so that they simultaneously touch the sphere at the center? Maximum, how many spheres you can place around a same size sphere such that they touch each other. So this is the arrangement, how it happens. This is the central sphere around which we can arrange 6 spheres. Plus on the top we can arrange 3 spheres which can touch each other, and then the bottom we can arrange 3 spheres we can touch each other. So the answer comes to 12 spheres. Okay. We'll move to the next one. Here you provided a water tank of dimension 20 by 5 by 10, and it has 307 cc of water. A few bricks each of size so much, 5 by 2 by 1, are fully submerged in the tank. Each brick absorbs 30% of its own volume. Just enough bricks are put in such that the water level rises completely to fill the tank. How many bricks were put in to fill the tank? So, we know the volume of the tank. Here, the tank volume is, 20 by 5 by 10, which comes to 1000 cc. Cc means cubic centimeters. We also know water in the tank, the volume of water in tank is 307 cc. So, remaining volume to be filled will be in the tank will be equal to 1000 cc minus 307 cc, which comes to 693 cc. Further, we know that the volume of brick is 5 by 2 by 1. What it means is, which equals to, of course, 10 cubic centimeters or 10 cc. Also, we are given that the brick absorbs 30% of water, of its 30% of its own volume, which is equal to 30% of 10 cc, which is its own volume, which is equal to 3 cc. This means 3 cc of water is absorbed by the brick. So, by immersing one brick, the water displaced by one brick will be equal to 10 minus 3, which is equal to 7 cc. Why? Because 30%, which is 3 cc, is absorbed by the brick, and the remaining 7 cc volume of the brick will be responsible for the rise in the water level. So we know the remaining volume which needs to be filled. We also know which is 693 cc, we also know the water displaced by one volume, one brick, which is 7 cc. So the total bricks required to fill the tank will be equal to remaining volume of remaining volume to be filled, which is 693, divided by water displaced by one brick, which is 7, which is equal to, when you divide that, it comes to 99 bricks. So in order to completely fill the tank or rise the water level of the tank to its full volume, we need to insert 99 bricks in the tank. Okay. We found the total volume of the tank, which is 1000 cc. We also knew that 307 cc was the existing volume in the tank. The remaining volume to be filled in the tank would be 1000 minus 307, which is 693 cc, which is yet to be filled. Further, we know the volume of the brick, which is 5 by 2 by 1, which is 10 cc. We also know that the brick absorbs 30% of water of its own volume. So 30% of its own volume is 30% of 10 cc, which is 3 cc absorbed by one brick. So the water displaced by one brick, because 30%, 3 cc is already absorbed by water, the remaining volume of the brick, which is 7 cc, will be responsible for the water displaced in the tank by one brick. So one brick, when inserted, will displace the water by 7 cc. So if one brick displaces the water by 7 cc, then the volume to be filled, which is 693 cc, will be displaced by how many bricks? Will be 693 by 7, which is 99 bricks. Okay, we'll move to the next one now. Total, now how many pages of size 21 by 25 centimeters can be made from a roll of 48 by 48 meters by 1.2 meters paper? You have to assume that the pages are cut perfectly. Now in this arrangement, this is the roll which we are provided. This roll is it's actually a bigger roll. It won't be so small, so I'm showing a cut line here, which means it's going to continue above. But the size, I know the length, but it is going to be 4800 centimeters, and this is going to be 120 centimeters. When I convert 48 by 1.2 meters to centimeter, it comes to 4800 multiplied by 120 centimeters. Because this is in centimeters, it's easier to convert this into centimeter instead of working with decimals. That's why I did this. So in this organization, I know that I have to first find out how many sheets of 21 by 25 centimeters that can fit in. Now, if I straight away divide 120 by 25, it comes to about 4.8, which means I can fit 4 landscape sheets, and 0.8 means almost 28 centimeter will be residue. Now, in that 20 centimeter residue, I cannot fit in. Now, how will I tell you? I'll tell you. So 4 landscape sheets, so 4 into 25 plus 0.8, whatever. So 4 into 25 is 100. So I know if I fit 4 sheets of 25 centimeter in landscape mode, like this, I can accommodate 4 columns. And then plus there will be a very big residue of 20 centimeter, which will be a waste. So I don't want to waste so much of sheet. So what I'm going to do is, I say, okay, instead of fitting in 4, what if we fit 3 landscape rows? What if we fit 3 landscape rows? So this is 25, so much, and this is 21. After this, this becomes 75, and then this becomes 45. In this 45, I will put one and then portrait sheets of 21 and 21. So I will be left with a residue of 3 centimeters by 4800. This is still less compared to what we were getting earlier. So I feel this happens to be kind of an optimal arrangement. So let's first calculate the landscape sheets. The landscape sheets in 3 columns. We're first going to count the number of sheets that can be fitted in landscape in 3 columns. So L, I'm writing landscape for L. Sheets will be equal to, there are 3 columns, so 3 multiplied by 4800 divided by 21. Why? Because 21 will be the will be the height of the rows. So I have to find how many such rows will come in the column in one column. So 48 by 21 will give me number of sheets in one column, multiply by, there are 3 such columns, which is equal to 3 multiplied by 228, approximately 228, because it comes to 228.57. 0.57 again is residue, which we cannot use it. So we won't be considering the decimal factor here. So 3 into 228 comes to 684. Portrait sheets, which are coming in 2 columns. P will be equal to, there are 2 columns, so 2 multiply by 4800 divided by 25, because 25 is the height. 25 is this height of the portrait sheet. So you have to find how many such sheets will come in one column, how many such rows of 25 sheets come in one column of 20 of portrait sheet. So this comes to 2 multiplied by 192, which comes to 384. When you add the total sheets which can fit in, comes to 684 plus 384, which is equal to 1068. So the total answer is 1068. Any doubts, any questions? Okay, we'll move to the next. Here you're given a graphic, which is there are a lot of people in a crowd. You have to count the total number of people in this picture who are wearing spectacles. You have counted the total number of people in the picture who are wearing spectacles. Okay. Please note, they have not counted the people who are wearing spectacles on the head. You just have to count the people who are wearing specs on their eyes, basically. So these are all the people. Now here there's just one error which I've done. This person is not wearing specs. Sorry, I've dropped a space. But this person nahi aayega. Ye wala galti se I've counted it. Instead, this is the guy who is wearing specs. It was a copy paste error. But these are the total 26. These are the total 26 faces, 26 people who are wearing specs in the figure. Okay. We'll now move to the next one. There are 2 friends. One is on a bike and another one in a car. They arrive in a parking lot. The chance that one car finds a parking space, or let me say probability that car finds parking, is equal to 0.1, Also, we are provided that probability of bike not finding parking is 0.1. It's written here. The chance that one in the car finds a parking space is 0.1 and one in the bike not finding a parking space is 0.1. What we have to find is the probability that one of them finds a parking space is what? So here, the probability that, one of them, let me write, either car or bike finds parking is equal to, there are two scenarios here. In first scenario, car finds parking and bike does not. Another scenario is where car does not find parking and bike does. There are two possibilities. Okay. Also, please note that in probability, and what do and or refer to? And refers to multiplication and or refers to addition. So, car finding a parking space will be, probability of car finding a parking space we know 0.1, because it's and we write 0.1 multiply by 0.1, and bike does not is also 0.1. Or means addition plus car does not find a parking space probability. The probability of that will be 1 minus 0.1, because in 0.1 is where car finds. So the car does not finding a parking space probability will be 1 minus 0.1 multiplied by bike does. So it's again 1 minus 0.1. So this comes to 0.01 plus 0.81. It comes to 0.82, which is the answer here. Okay. So the probability that either one of them finds a parking space will be 0.82. Okay. With this, we end today's session. Thank you so much for your time.